all the first coordinates in the first group, first set, and the second coordinates are arranged in the second set. So the first coordinates are going to be 1, 2, 6 and 8. And the second coordinates are going to be 3, 5, 7, 9. 3, 5, 7, 9. As per the given question, here this contains the images of 1, 2, 6 and 8. The image of 1 is going to be 3, that means 1 is associated with 3, and the image of 2 is going to be 5, so 2 is associated with 5, 6 is associated with 7 and 8 is associated with 9. If we observe the arrow diagram carefully, this arrow diagram depicts that distinct elements of set A are going to have distinct images of set B. As because no two distinct elements have the same image, this function is going to represent a one-to-one function. So instead, every time we need not draw the arrow diagram, just simply check the second coordinate. If second coordinates are all distinct, then obviously that particular function is going to represent a one-to-one function. Let us see what happens if the second coordinate is repeated. Let me change some example here. In the example, instead of 7, if I take 5, that means even though I don't have 7 here, then I have taken as 5. That means I have taken the image of 6 as 5, and the remaining all remains same. Now what is observed here is, we observe that the image of 2 is 5 and the image of 6 is also 5. As because the second coordinate is repeated, we can understand that these two distinct elements are going to have the same image 5 in the arrow diagram. So distinct elements are going to have the same image, therefore this will not represent a one-to-one function. So that is the reason, if second coordinate is repeated, or the second coordinates are not distinct, then you can confirm that the function is not going to be a one-to-one function. If second coordinates are all distinct, then we can say it as a one-to-one function. So what is going to be the alternate definition of one-to-one function? So a function f of ordered pairs is said to be one-one function if no two ordered pairs have same second coordinate, or otherwise we can say if second coordinates of all the ordered pairs of f are distinct, the function f is said to be one-one function. So this is the other kind of concept what actually you have, and this is the alternate definition of one-to-one function. So based upon the kind of question you get, we use either the previous concept or this concept or this definition. And we have next, we have one more alternate definition for one-to-one function. Let us see what is that. The next alternate definition of one-to-one function. Sometimes what they do is the functions would be given as graphs. Instead of giving you the formula definition or formula rule, or instead of giving the ordered pairs, the next thing that what they do is they'll give the graph. By making use of the graph, you are supposed to check whether the function is going to be a one-to-one function or not. So here, let us go ahead with some graphs of some functions. As already we know that the graph of a relation is said to be a function if the vertical line drawn is if it is meeting the curve at the most one point, then the curve is going to represent a function. So as this is all called as a vertical line test that we have seen in the definition of function. If you observe carefully in this example, in this example, there is some curve given to you, and this curve is obviously representing a function because the vertical line drawn parallel to y-axis is going to intersect the curve at the most one point. Anywhere you draw a line drawn parallel to y-axis, it can meet the curve at the most at one point. Whenever the vertical line drawn parallel to y-axis, it is meeting the curve at the most one point, then obviously the curve is going to represent a function. So, and this is already a function. Now I need to confirm whether this particular function is going to be a one-to-one function or not. So for function, we go with the vertical line test. To check whether the function is going to be a one-to-one function or not, you are supposed to go with the horizontal line test. Now exactly same way, if I draw a horizontal line parallel to x-axis, anywhere you can draw a horizontal line parallel to x-axis. If it can meet the curve at the most one point, then that particular function is going to represent a one-to-one function. So here, anywhere you draw a line, horizontal line parallel to x-axis, it is going to meet the curve at the most at one point. Therefore, this particular function is going to represent a one-to-one function. So here you can say f is going to be a 1-1 function. So here, in a similar way, I go with some other example where I give the graph of the function. Now judge whether the function is going to be a one-to-one function or not. So here, if I take say the graph of some so this is a graph of some function. So observe carefully, wherever I draw the vertical line, it can meet the graph exactly at not more than one point. Therefore, this graph is going to represent a function. Because it is going to represent a function, now I have to check whether this particular function is going to be a one-to-one function or not. So here I go with the horizontal line test. Wherever I draw a horizontal line parallel to x-axis, it is going to meet the x-axis at more than one point. Because it is going to meet the x-axis at more than one point, we can understand that two different elements are going to have the same images. Therefore, this curve does not represent a one-to-one function. So finally, whenever the graphical function is given to you and they ask you about to check whether the function is one-to-one or not, the possibility is to go ahead with the horizontal line test. So any line drawn horizontal parallel to the x-axis, if it is going to meet the curve at exactly one point, then the function is going to represent a one-to-one function. If it is going to meet the curve at more than one point, then obviously the function is not a one-to-one function. So the definition of one-to-one function by using the graph, so is nothing but the graph of a function. The graph of function represents a one-to-one function. Represents a one-to-one function. Represents a one-to-one function if the horizontal line, drawn parallel to x-axis meets a curve at exactly one point. So whenever the graph is going to meet the horizontal line is going to meet the graph at exactly one point, the graph is going to be called as going to represent the one-to-one function. So if I draw a line parallel to horizontal line parallel to x-axis, it's going to meet the curve at exactly one point. Therefore, you can say the curve f is a one-to-one function. So these are the different ways of the questioning of one-to-one problem, one-to-one function. So in the initial example, we have seen if the function rule is given, how to judge whether it's going to be a one-to-one function or not. In the second level, we have seen if the function is given as ordered pairs, how to judge whether it's going to be a one-to-one function or not. And in the third case, we have seen If the graph of the function is given, we have seen about how to judge whether the function is going to be a one-to-one function or not. So, after this, here let us go for some important note. Let's go for some important note. In this important note, what you are going to see is we are going to see about how many one-to-one functions are possible from a given set A to given set B. Already we know that the number of functions from set A to set B is also given by n of b to the power of n of a, which we have seen in the last class. And now we are going to see about how many one-to-one functions are possible from set A to set B. So, but before going to this, let me just go with some example. Let me take two non-empty sets, say A and B, contain elements 1, 2, 3, 4. Now, if I have taken two non-empty sets 1, 2, 3, 4 in this way, then how many functions are possible? The question is, how many functions are possible from A to B? So, observe carefully, number of functions possible are number of functions possible from set A to set B is given by n of b to the power of n of a. So, here the set B contains 2 elements and set A contains 2 elements. So, the number of functions possible are 4. So, 4 functions are possible. So, let me draw those 4 functions. As per the definition of function, a relation is said to be a function if every element of set A is associated with a unique element of set B. So, here this is a function because every element of set A is going to be associated with a unique element of set B. So, this is a function. This is one of the function possible. This is a second function possible. This is a third function possible, and this is going to be the fourth function possible. So, the total number of functions possible if A contains 2 elements, B contains 2 elements is going to be 4 functions. So, the number of relations is going to be different. Number of relations is going to be given by 2 to the power of n of A into n of B, that is 2 to the power of 2 into 2, 2 to the power of 4, that means 2 to the power of 4 is 16. So, the 16 relations are possible from A to B. Out of those 16 relations, only 4 will become functions, and those 4 functions are drawn here. And now, our task is to confirm out of these 4 functions, how many functions are going to be one-to-one functions. So, first of all, to know about one-to-one function, you people know about the definition of one-to-one function. As per the definition of one-to-one function, different elements should have the different elements of set A should have the different images. Observe carefully the first one. Here, F1 cannot be a one-to-one function because here distinct elements have got the same image, and therefore it is not a one-to-one function. Whereas coming for the second one, here distinct elements are having the distinct images, so therefore this function is going to be a one-to-one function. And here third case, here distinct elements are having the distinct images, therefore this is also a one-to-one function. And coming for the fourth case, here distinct elements are having the same image, therefore this function is not a one-to-one function. So, out of 4 functions, observe carefully, out of these 4 functions, only 2 functions became one-to-one functions. So, here number of one-to-one functions are from set A to set B is equal to 2. So, I have given you the total number of one-to-one functions in this example is 2. Now, do we have any formula to know about the number of one-to-one functions? Here we observe carefully, we have a formula to find out the number of functions from A to B. It is n of b to the power of n of a. In a similar way, here we got out of those 4 functions, we have drawn them, we have checked them. Instead of drawing them each time, do we have any formula which gives us the total number of one-to-one functions directly? The answer for it is yes. So, now we are going to see the formula to find out the number of one-to-one functions from set A to set B. So this is, I have done it manually. Out of 4 functions, we have got 2 functions as one-to-one functions. Now we are going to introduce the formula to find the number of one-to-one functions from set A to set B. So the first important note is number of one-to-one functions from set A to set B is going to be equal to n of B P n of A. Here observe carefully, this is a formula from the topic called permutations, which you are going to learn in your higher classes. So n of B P n of A is a formula to find out the number of one-to-one functions from set A to set B. The formula what we have in the permutations is NPR. So NPR is equal to n factorial by n minus r factorial, where n is always greater than or equal to r. Right now we are going to accept this formula. In further classes we are going to learn about the formula more, but here we need to just apply the formula and get the number of one-to-one functions from set A to set B. So the formula here is n of B P n of A, that is n of B, number of elements in set B, P n of A. That means we can get the formula as n of B factorial by n of B factorial by n of B minus n of A factorial. And here we know that n of B must be greater than or equal to n of A. So here the factorial indication notation means n factorial means the product of all the natural numbers up to n. So exactly in the previous example, if you observe carefully, in the previous example A contained 2 elements and B contained 2 elements. So the number of one-to-one functions is given by the formula in the previous case was 2p2, because whenever n of A is 2, n of A is 2, n of A is 2, n of B is 2, that is the example what you have taken in the previous. So in that A contained 2 elements, B contained 2 elements. So number of one-to-one functions will be, number of one-to-one functions will be, number of one-to-one functions from A to B is 2p2. 2p2 is nothing but 2 factorial by 2 minus 2 factorial. That is 2 factorial means the product of all natural numbers up to 2, that is 1 into 2 gives you only 2 here. 2 minus 2 is 0. 0 factorial value is going to be 1. So 2 by 1 is going to be 2. So number of one-to-one functions from set A to set B in the previous example was 2, which you have got by using the formula. So finally, the formula to find the number of one-to-one functions from set A to set B is given by n of B to P n of A. Remember that this is the functions, one-to-one functions from set A to set B, and make the necessary changes if they ask you number of one-to-one functions from set B to set A. If they ask you number of one-to-one functions from set B to set A, it will be n of A P n of B. So this is the formula to find out the number of one-to-one functions. And observe carefully, the formula is valid only when n of B is always greater than n of A. As you know, NPR is valid only when n value is greater than or equal to r. So exactly same way, this formula of one-to-one functions is also valid only when n of B is greater than or equal to n of A, or n of A is less than or equals to n of B. So here we have got some important note. So we have got some important note number 2. The note number 2 says that one-to-one functions are possible from A to B only when n of A is less than or equal to n of B, or n of B is greater than or equal to n of A. So here we have discussed about the 2 important notes in the case of one-to-one function. So one is the formula to find the one-to-one function. The second thing is the condition to check whether one-to-one functions are possible or not. Based upon the second property, let me go ahead. In case n of A contains more number of elements than B, is there any possibility of getting one-to-one functions? Say, check some example. In case if A contains more elements than B, if A contains more than elements in B, then is it possible to go with one-to-one function? So let me just test by example. Let us suppose that n of a is going to be equal to 5 elements and n of b is equal to somewhat like 3 elements. Let's say take some example. Say I take a, b, c, d, e and I take b as only 3 elements, say 1, 2, 3. Is it possible to create a one-to-one function between these two sets? Here, if I try to make a one-to-one function, distinct elements must have distinct images. So here, if I try to get distinct images here, D should also have a different image compared to the others. E should also have a different image, and I can't leave D and E alone here because it must be a function. If it is a function, obviously every element in set A must have a unique image in set B. That means to make it as a function, D should have an image and E should have an image, but D does not have any other element, E does not have any element to make an image. Therefore, these two elements are going to become free. Therefore, this will not become a function at all. That means in this case, if I try to get the image for it, I have to associate this element with either 3 or 2 or 1. The same way, for this also I have an image associated with 2 or 3 or 1. That means in this case, what happens is different elements get the same images. So obviously, this kind of function will not become a one-to-one function. So therefore, whenever n of a is greater than n of b, so whenever n of a is greater than n of b, number of one-to-one functions is 0. So in the case if n of a is greater than n of b, the number of one-to-one functions is going to be 0. So one-to-one functions are possible only when n of a is less than or equal to n of b. And remember that these are the one-to-one functions from set A to set B. And I have told you, or I have introduced you so far about the first type of function called as one-to-one function. And now let us see the second type of function. A second type of function after one-to-one function is many-to-one function.